the derivatives of the following functions. So in part A, we got f as a function of s. So you can think like x root s times quantity s minus 1. So it's a product of two functions, square root of s times s minus 1. But the question in this case, we can simply get rid of this product. Okay, so or sometimes the question asks us to not use product rule. I mean, we can use product rule, that's from the upcoming section, but here this is so simple, we can simply get rid of this product and find the derivative. This is a quotient. We can use quotient rule to find the derivative, but this is so simple, or let's not say so simple, we can get rid of this fraction, so we don't have to go use the quotient rule. And by the way, when we have root of something, that's a square root of something, right? So this is same as x raised to 1/2. So let me rewrite this. F as a function of s is, this is s raised to 1/2. Inside is just s minus 1. S means s raised to 1. There's nothing means 1. Now when we multiply, we add the exponents. So here s 1/2 and s 1/2 plus 1. It's like when we have x raised to a times x raised to b, we have the same base x, we add the exponents a plus b. If these are numbers, then just simplify. So here 1/2 and 1 3/2, right? 1/2 means 0.5 and 1.5, which is 3/2, minus that times 1 is just that, s raised to 1/2. Now this expression is like x raised to a power in each case, and we know that the derivative of x raised to some power is just n x n minus 1. That's the power rule. Okay, now we find the derivative. So 3/2 s 3/2 minus 1, which is 1/2, minus again power rule 1/2 s 1/2 minus 1. Okay, 1/2 minus 1, negative 1/2. We may leave here, but the best answer would be get rid of this negative exponent. For we put this on the bottom. So this is 3/2 s raised to 1/2. You may leave that, or this is pretty much root s, or you can write s raised to 1/2 minus, here is 1/2, that negative put on the bottom, s raised to positive 1/2, or root s. Okay, let's do part B. So here we can simplify and get rid of this fraction. So we got two terms on the top, only one. So remember, when we had, let's say, a over x plus b over x, and when we add these two fractions, oh, we got common denominator and a plus b on the top. But if we have two terms and one bottom, we can go backward like this, okay, expand, so that we can simplify. So let's do that. Root x over x squared plus x over x squared. So this is how we can expand and get rid of this quotient or fraction. Now root x means x raised to 1/2 on the top, x squared on the bottom. So what happens is, when we have x raised to a power on the top and same x raised to another power on the bottom, we have the same base x, the top is there, move up, that becomes negative of whatever this one. If this is negative, then that would be negative of negative means positive. So this is, in this case, x raised to 1/2 on the top, 1/2 minus 2, move up, minus 2, 1/2 minus 2 is negative 3/2. Okay, I'm kind of skipping a step, but this is x raised to 1/2. 1/2 minus 2. 1/2 minus 2 is negative 3/2. Here we have two options. We can think x raised to 1. 1 minus 2 is negative 1. Or one copy of x cancel from top and bottom. That leaves 1 over x. 1 over x is same as x raised to negative 1. Or simply like this one, plus in the middle, x 1 minus 2 negative 1. So this is how we get rid of the fraction. Okay, now we can use the power rule for each term, x raised to n, x raised to n. So now the derivative is then bring this to the front by the power rule, negative 3/2 x negative 3/2 minus 1. Negative 3/2 minus 1. 1 is 2/2, so negative 3 minus 2, negative 5/2. Plus negative 1, okay, plus minus, let's put parentheses, x negative 1 minus 1. Negative 1 minus 1, that's negative 2. We may leave here, but the best answer would be negative 3 over 2. Put this factor on the bottom so that we don't have to write negative exponent, x raised to 5/2. Okay, plus minus minus negative, put on the bottom, x squared, and 1, there is nothing means 1 on the top. So 3 over 2 x raised to 5/2. Okay, that one is 5/2. Minus 1 over x squared. Final.